boiling the water, so that there should not be any air inside the water, because it will create the problem during to taking the water equivalent to it. Because if there is air, that can take any space inside the bottle. Once if there is any space inside the bottle, means the experiment is going to be failed.
So you want to increase the precision.
Exactly, and
Preciseness.
I want to remove the air only, so that there should not be any air inside the sample. Then after filling the water, then keep it here only at 30 degree, 35 degree, whatever you want, and let it for till there is no any gap inside the water, and the excess amount of the water should splash out from this. You can see the extra amount of the sample is coming out, because at temperature obviously volume will expand, so it will cover the whole area of the bottle. And after 30 or 35 minutes, take it out, clean it, and wait, let it come into the room temperature. Then again you will take the weight. Then you have initial weight, you have water equivalent weight, and you have the weight of the fuel. So density of that particular fuel is equal to weight of fuel and divided by density water equivalent weight of the water. So you can say that the density of fuel divided by density of water. Okay, that is basically the method. So let him complete first, then he will let you know the calculation part. जब ये करेगा ना, उसके बाद बता। ओके, कौन सी जो लगा रखी यही है? नहीं, इसका वेट नहीं किया, बस जब करेगा तब बता। ये बता see, you have already completed one sample. This is 45.9107. This is the weight of the sample plus bottle. Okay, so after subtracting the empty weight of bottle, then this is the weight of the sample. Okay, and I think this is the weight of water equivalent weight. Now, weight of sample divided by water weight, that water equivalent weight, and this is your density. At what temperature you are kept here? It depends on the condition of the sample. If it is VR may be kept at 100 or 75 degrees centigrade. But if it is sample in semi-solid form, so this we can kept at 72 or 70 degrees centigrade. It depends on the condition of the sample. Okay, then you can convert. Density is 62.5 is this much. Now you can convert the density at 15 degree by we have a density conversion book. From there you can convert at 15 degrees centigrade, and we will report the density at 15 degrees centigrade. Why we are reporting the density at 15 degrees centigrade?
65 high.
Exactly. I already talked to you. Okay, so everything, whatever result we are sending to the refinery, there is a reason why we are sending the result at 760 mmHg. We should be at 880, at 760. Okay.
There is a condition that's normal, that the absolute temperature and the absolute pressure, that's to standardize the numbers for all crews.
Exactly. So that is the main reason. So let it complete. Then after that, if we will find some time after calculation, then we will do the smoke point. Smoke point, which is very important in ATF, aviation turbine fuel. See, smoke point is a index also, which can tell you the presence of aromaticity. If smoke is high, there is lots of smoke, then definitely you come to know my fuel is high in aromatics. If smoke is low, then it is free from, not free but low in aromatics. And another one is aniline point. Aniline point is also an index of aromatics. What you will do, you will take the same quantity of the sample and same quantity of the normal heptane, because normal heptane is non-aromatics compound, and the sample which you are taking, you want to know the aromatic aniline number of that particular number. When you mix up aniline and that sample and normal heptane, so you will find the layers. So you will have to heat up at which temperature it is mixing all together or it is separating each other. So difference to mixing and separating should not be more than 0.3 degrees centigrade. That will be your aniline point. But before that, to using the aniline, first you will have to calculate the aniline point of aniline. For that, what you require? You require aniline, you require normal heptane. Mix up together, you will find the two layers. Now heat up, where it will mix up, note down the temperature and take it out and shake, and now see where two layers are separating. Again you can check the temperature. So the temperature between these two, mixing and separating,